students. I hope everyone is doing well. So as you all got the result where some want to put for the revaluation, where some want to go for the photocopy, okay, some are not happy with the marks what they have got, okay. Already in a PU board website they have given the notification regarding the count of the marks as well as revaluation as well as for the photocopy of whatever the papers you want, okay. Please go through the website, okay. I'll going to give a link in the description box. I hope you find it very useful, okay. So till now we have completed the mind map of almost all the things as I have promised, okay. This is some of the previous year questions on the aldehyde, ketones and the carboxylic acid, okay. I hope you may find this very useful, okay. And some are asking some more videos based on the oxidizing agent and the reducing agent. Yeah, definitely I tried to do how much it is possible from me, okay. And very less time is available, and I request you people not to wait for the postponement of the Karnataka CET exam. Instead start reading, okay. And if it postpones, then it will be a very happy thing. As of I know, it will not going to happen, okay. So please, if it happens, I'll be also the happiest person, okay. Please concentrate on the study. And here is, like you could see the question, that propanoic acid undergoes HVZ reaction to give chloropropanoic acid. The product obtained is stronger acid than propanoic acid, weaker acid than propanoic acid, as stronger as propanoic acid, stronger than dichloropropanoic acid. So dear students, this I have already discussed in the mind map of a carboxylic acid. I hope you people remember that one. So in that one I have mentioned about the some of the reactions or some of the yesterday I just uploaded some of the named reaction video. In that one, if you have seen the HVZ reaction I have discussed. So HVZ is nothing but what? Hell-Olhard-Jelinski reaction, okay. It is simply the halogenation of a carboxylic acid to give alpha halocarboxylic acid. Means when the carboxylic acid, I'll just going to write here, when the carboxylic acid is treated with what? Halogen in presence of a red phosphorus, this halogen, okay, will be substituted to the alpha carbon, okay. The product will going to get what? Carboxylic acid with a halogen substituted, okay. So this is what the HVZ reaction, but here they are not asking you the reaction. They already have told that propanoic acid undergo HVZ reaction to give chloropropanoic acid. That is, propanoic acid means what? CH3CH2COOH. This is what the propanoic acid. When undergo HVZ, they only have told that the product is chloropropanoic acid, that is CH3, as alpha halo substituted will going to get, so that the product is CH3CH, where the chlorine is substituted over here, okay. This is the product. So what they are telling is, when we compare this propanoic acid and this chloropropanoic acid, okay, here you could see the product obtained is stronger acid than propanoic acid, weaker acid than propanoic acid, as stronger as propanoic acid, or stronger than dichloropropanoic acid. So dear students, here thing is, when we compare propanoic and the chloropropanoic acid, in this product we have chlorine, okay, and chlorine is one of the electronegative, highly electronegative element. Electronegativity means what? Which has a capacity to attract the electron towards itself. That is what the definition, and it is one of the electron withdrawing group, we could say. So acidity or acid property is discussed when the polarity is increased, so that H plus ion should come out very easily, okay. This chlorine, okay, this chloride at like ion, what it does, it helps to create the polarity between the OH group, so H plus releases very easily. Okay, but here what is happening, we don't have any such electron withdrawing group over here. Okay, so we know that electron withdrawing group increases the acidic property. Okay, so this chloropropanoic acid is more stronger than the propanoic acid. Okay, so it's an option A, which is correct. It is because this chlorine will going to act as what? Electron withdrawing group, which increases the polarity of a OH over here and releases the H plus ion very easily. Okay, I hope it is clear. The answer is option A, which is. So this was the question asked in 2019. Yes, my dear students. So the next question is from 2019. As I had told, the weightage of the aldehyde ketones in the carboxylic acid is around 4 to 5 questions definitely. Okay, that is how you could see here. So here the question you could see, P when reacts with hydrogen over palladium in presence of a barium sulfate gives Q. Okay, when this Q is allowed to react with a concentrated sodium hydroxide, okay, followed by treating with a dilute HCl, it gives what? The respective R and S. So here the R and S form benzyl benzoate when treated with each other. Okay, hence P. So thing we need to know is only the beginning of the compound, that is what is the main reactant over here. So dear students, we have discussed about this in the preparation of what? The aldehyde itself. I hope you remember. Okay, during the preparation of aldehyde, you could see over here. Okay, so here I have mentioned, see here, when acyl chloride is treated with a hydrogen over palladium in presence of a barium sulfate gives what? Respective aldehyde. Okay, so the same thing is over here. When the P is treated with hydrogen over palladium, we will going to get what? Q. Okay, so here you could finish. No need to go through even the further reaction as well. Why? They have asked you only P here. Okay, if you know the role of hydrogen over palladium and barium sulfate, where exactly it is used, it is a Rosenman reduction reaction. So what is the reactant we're going to use here? That is acyl chloride. Okay, among the 4 option, which is, it is option B, which we're going to call it as a acyl chloride. Okay, so P that we are using is what? This acyl chloride. Okay, I'm going to show this is P. Okay, here what is happening, when it is treated with the hydrogen over palladium, it's a Rosenman reduction reaction. The product will be what? We will going to get the respective aldehyde. This is what the Q we are getting. Okay, next what they are telling, when it is treated with a concentrated sodium hydroxide. Dear students, even this have discussed in the named reaction video, where when any aldehyde or the respectively specifically aldehyde containing, means which don't have a alpha hydrogen atom, when treated with the concentrated sodium hydroxide, okay, it results in the formation of the salt of a carboxylic acid and the primary alcohol. I hope you remember. Okay, so here, so this is what? The Cannizzaro reaction. So we will going to get product what? The respective the carboxylic salt, that is COONA, followed by, we will going to get what? The respective primary alcohol, dear students. Okay, this is what R and S. Okay, so this is what R and S. So this is what complete reaction. If you know at least any one half of the reaction here, dear students, then you can predict the answer very easily. So the most important is the first half. Okay, so the answer is benzoyl chloride. So it is very necessary to remember the role of a reactions and the reagents and the reactant that the reaction is going to start. Then it helps very predict the answer in an easy way. Okay, I hope you find it very useful. So let us move to the next part, that is from the 2018. The appropriate reagent for the following transformation is, the appropriate reagent for the following transformation is. So what I want to know here, I am not going to concentrate anything. The only thing is where the change is happening. Okay, see here we have CO group, that is a ketone group, and here this ketone group is, that I'm going to write here, the ketone group over here is converted into what? It is getting converted into CH2 group. Okay, oxygen is removed, in that place hydrogen is added. So what is this, students? It is simply a reduction process. Reduction means what? Addition of a hydrogen, removal of a oxygen. So we have studied some of the named reaction in the previous video that I'm going to mention in the description box. Okay, please follow that link. Okay, this is either Clemmensen reduction reaction or Wolff-Kishner reduction reaction. Okay, ketone group is converted, the carbonyl group you could say is converted into a respective hydrocarbon. So here we will going to out of 4 options we will get sure that it is either A or B. Okay, now the question comes, which is the correct answer? See, thing is, do concentrate. When I say zinc amalgam over HCl, we have hydrogen chloride here. So this HCl, okay, this HCl, when it is added to this compound, we have a alcoholic group. Okay, this alcoholic group is not protected easily. Okay, this alcoholic group tried to react with the acid that are present, but here what is happening, here what is happening, we are getting OH group as it is, even in the reactant as well as a product. Okay, if we use this hydrazine, okay, in presence of a potassium hydroxide and the ethylene glycol, since we have potassium hydroxide which is basic in nature, will not allow or will not react with this OH group, or it protects the OH group. So even in the product also we are going to get OH as it is. So it is the option B which is correct. Okay, I hope you find it useful. So let us discuss about the next question.